Bismillahirrahmanirrahim. Today we will discuss about exercise 6.3, question number 1, part 5 of class 9 mathematics. That is available on page number 126. The part 5 is question number 1. Find square root by factorization. Part 5. That is 4x to the power 6 minus 12x cubed y cubed plus 9y to the power 6, and in the denominator 9x to the power 4 plus 24 x square y square plus 16 y to the power 4. Now we need to make the square root of it. For square root, it must be the square of anything. If this is not the square of any expression, we can't make any square root of this. But in this question, you can see that this is numerator and this is denominator, a whole fraction. So we need to make a square root of it. We can consider these are two questions. Just we have done yesterday. This is question number 1 and this is question number 2. We need to make both the squares. For numerator, 4x to the power 6 minus, or I can do here, the numerator 4x to the power 6 minus 12x cubed y cubed plus 9y to the power 6. This is this numerator. We need to make a complete square of it. You can see that there are two values which are with positive sign and one value with negative sign. It means that this is complete whole square just of the form of a minus b whole square. So in order to make this, we need two positive squares that are, first is 4x raised power 6. 4 is square of 2x raised power 6 is square of x cubed. So we can write this thing as 2x cubed whole square. Another square that is positive square plus 3 y raised power 6 means y cubed square. This is called b square because 3 square is 9 and y raised power cube square, that is y raised power 6. This is just like a square plus this is b square. After that this is minus and some expression. We need to write this in the language in the form of minus 2ab and confirm it whether this minus 12x cubed y cubed will be appears or not. So minus 2a and b. The value of a is beneath this square and the value of b is beneath this square. So beneath this square, this is the value of a, that is 2x cubed. So you need to write here 2x cubed. And beneath this square, that is 3y cubed. Now you can see that a square plus b square minus 2b, but we need to confirm it. 2 to the 4, 4 3 is 12, this is 12 and x cube and y cube, and that's it. It means this is a complete square of a square plus b square minus 2ab time. So this is like a minus b whole square. This is minus sign, the value of a is 2x cubed beneath this square, and the value of b here is beneath this square, that is 3y cubed. And that's it. So in the numerator, we need to write, instead of this, we will write 2x cubed minus 3y cubed whole square. After that, for denominator, we will do the same thing. denominator is 9x raised to power 4 plus 24x square y square plus 16y raised to power 4. Now make the complete square. You can see that all the values are with positive sign. It means that it can be the formula of a plus b whole square, because a plus b whole square is a square plus b square plus 2ab, all the signs with negative. Oh, sorry, positive. All the signs with positive. So it can be the a plus b whole square formula. So for that verification, again we need two positive squares. That is, first is 9x raised to power 4. 9 is square of 3. So 3x raised to power 4 is x square square. This is, you can say, a square. Another square is 16y raised to power 4. 16 is square of 4. So we can write it as 4y square square. This is b square. We are done with a square plus b square. And we are left with 24x square y square. This thing we can write in the form of, in the language of plus 2a and b. And confirm it whether it is 24x square y square or not. So we have the value of a, that is beneath this square, that is 3x square, and the value of b, that is 4y square. Now confirm it. 2 3s are 6, 6 4s are 24, and x square y square, and that's it. So it means it is of the type of formula a square plus b square plus 2a. So we can write it as 3x square, this is a plus 4y square, this is b and whole square. So instead of writing this, we can write 3x square plus 4y square whole square. Now we can make easily the square root of it, because we found it a complete square, as a complete square. Either you can make a complete square within a fraction, because the square, whole square on it and on the denominator, that is 2x cubed minus 3y cubed, and in denominator that is 3x square plus 4y square whole square. So we need to find the square root. So apply square root sign on, that is 2x cubed minus 3y cubed over 3x square plus 4y square whole square, and apply square root on it. And after that you are left with only the answer, that is 2x cubed minus 3y cubed and 3x square plus 4y square. And that's it. This is the answer. And this was your part number 5. After part 5, we are left with part 6, 7, 8, and 9 of question number 1. But firstly, we will solve part 8 and 9 because it is very easier. And part 6 and 7 are quite very different from these previous methods. So this thing will disturb your concepts. So firstly, we will solve part 8 and 9, and after that, we will solve part 6 and 7. So talking about part 8. Part 8 is to find the square root of x square plus 3x plus 2, x square plus 4x plus 3, and then x square plus 5x plus 6. These are 3 expressions We need to find the square root of them. But we can find the square root if this is a complete square. So we can see that this is x square plus 3x plus 2. This is a quadratic expression. You can see that three expressions. So you can consider that these are three questions. That needs factorization. That needs midterm breaking. So for x square plus 3x plus 2, x square plus 3x plus 2. The x square coefficient is 1. 1 multiplied by 2, that is 2. So for midterm breaking, we need a pair of number whose multiplication answer is 2 and whose addition answer is 3. So both numbers are 2 and 1 or 1 and 2. So midterm breaking, that is 1x plus 2x plus 2. This is midterm breaking. So what is common here? X is common, so x plus 1 will be left here. And what is common here? 2 is common. So you can write 2 here, x plus 1. After that, when you found that both are same, then you can write x plus 1 and then x plus 2. So instead of x square plus 3x plus 2, you can write x plus 1 and x plus 2. After that, we are left with x square plus 4x plus 3. So this thing also requires midterm break. X square plus 4x plus 3. You can see that now x square coefficient, that is 1 multiplied by 3, that is 3. The midterm is 4. So obviously two numbers whose multiplication answer is 3 and whose addition answer is 4, that is 1 and 3. So x square plus 1x plus 3x and plus 3. This thing makes the midterm breaking. So what is common here? X is common, x plus 1. What is common here? 3 is common. Again x plus 3 is common plus 1 here. You can see that both are same. So you need to write it once and then x plus 3. So instead of writing x square plus 4x plus 3, you can write x plus 1 into x plus 3. After that, x square plus 5x plus 6. For this, x square coefficient is 1 multiplied by 6. So 1 multiplied by 6 answer is 6. A pair of numbers whose multiplication answer is 6 and whose operative answer is addition answer is 5, 2 and 3. X square plus 2x plus 3x plus 6. What is common here? X is common, then x plus 2. And what is common here? Plus 3 is common. Again x plus 2. So x plus 2 will be right once and x plus 3. So instead of writing x square plus 5x plus 6, you need to write x plus 2 into x plus 3. And that's it. Now after making all the factorization, x plus 1 into x plus 2 for this, and this is for this, this is for this. So we can see that the things are repeating. Means to say this x plus 1 and this x plus 1. This x plus 2 and this x plus 2, this x plus 3 and this x. So x plus 1 multiplied by this x plus 1 makes x plus 1 whole square. X plus 2 multiplied by x plus 2 makes x plus 2 whole square. x plus 3 and x plus 3 multiplication makes also whole square. So we can write as x plus 1, x plus 2 and x plus 3 whole square. After realizing that this is a whole square, we can make its square. So the last step is apply square root on it. After applying square root sign, you can cancel this square with that square root and you are left with answer only x plus 1, x plus 2 and x plus, and that's it. This was your part number 8 and part number 9 is same as it is. Part number 9 is again x square plus 8x plus 7, 2x square minus x minus 3, then 2x square plus 11x minus 21. Again, this is the same question. We need to make a midterm breaking of this, this, and this. I have already done with this factorization x square plus 8x plus 7. After its factorization, when you are done with its factorization, it is left with x plus 1 and x plus 7. So, for 2x square minus x minus 3, its midterm breaking is 2 multiplied by minus 3, answer is minus 6. And the midterm is minus 1x. So we need a pair of numbers whose multiplication answer is minus 6 and whose operative answer is minus 1. That is minus 3 and 2. Because minus 3 multiplication with 2 is minus 6 and minus 3 plus 2 answer is minus 1. So we can write it as 2x square minus 3x plus 2x and minus 3. So what is common here? Only x. So after taking x common, we are left with 2x minus 3. What is common here? Nothing is common except plus 1. So plus 1 and again the same thing. So both within brackets are same. Expression 2x minus 3 and then x plus 1. And now you can write instead of this expression 2x minus 3 and x plus 1. Now for this term 2x square plus 11x minus 21. This 2 will going to multiply to this minus 21, that makes minus 42. Now we need a pair of number whose multiplication answer is minus 42 and whose operative answer is plus 11. So both numbers are 14 and minus 14, 14 and minus 3. Because 14 multiplication with minus 3 answer is minus 42 and 14 minus 3 answer is plus 11. So make the pair of it, that is 2x square plus 14x minus 3x and then minus 21. This is midterm breaking. Now 2x is common, x plus x is outside there and 2 multiplied by 7, that is 14. What is common here? You can see that first is minus sign is common and then 3 is common here. So minus 3 is common and all the signs are changed. Both are same brackets. Write it once and then towards minus. Now write instead of this x plus 7 and 2x minus. Now think about it. What is going to happen here? Think about it. You can see the repeated items in this expression. That is x plus 1, then x plus 1, x plus 7, and x plus 7, 2x minus 3, and 2x minus. So nothing is left. All the things are multiplying and making square of them. X plus 1 square, x plus 7 square, 2x minus 3 whole square. So you can write this thing as x plus 1, 2x minus 3, x plus 7 whole square. So after applying square root on it, you are left with, if you are going to apply square root on it, this square cancel with that square root and you are left with the answer only. That is beneath the square. So your answer will be x plus 1, 2x minus 3 and x plus 7. This is your answer. And that's what you are, that's the part 9 that you have done easily. Now the part 6 and part 7, which are totally different from these methods, you need a little bit concentration more rather than previous questions. The part 6 is you need to make a square root of it. But this is not the complete square. This is not the complete square. You need to make its factorization by let this variable into another variable. You can see that this is x plus 1 over x whole square. Firstly, you need to open it. This is of the type of a plus b whole square. So open it. That is a square mean to say x square plus b square mean to say 1 over x whole square, after that plus 2a and b. The value of a is x, the value of b is 1 over x. Or you can say that the value of a is beneath this square, x, and the value of b is beneath this square, 1 over x. Or you can see that this x can cancel to this x. After that, we are left with minus 4 x minus 1 over x. Don't need to multiply this minus 4 inside x minus 1 over x. Now you are left with x square plus 1 over x square plus 2 minus 4 into x minus 1 over x. Now the question arises here, can we do this simplification to minus 4? We can't do it because this minus 4 is multiplied. This is attached with x minus 1 over x. So according to the mass rule, first is division, then is multiplication, after that addition, and then is subtraction. So multiplication, right, is first. So we can't do this simplification. Most of the students do this 2 minus 4, answer is minus. We can't do this. Okay. Now I am applying bracket here. If I am not applying bracket, there will be no any difference. But for some method, x square plus 1 over x square, I am applying here the method. And for this equation, I am writing this equation is equation number 1. You can see that here are x minus 1 over x Here x raised power 1, there is x raised power 1, and for this expression x raised power 2 and x raised power 2 square are there and linear power are there. So we can let the variable or you can write here, let this smaller power x minus 1 over x is equal to 1. We have done this type of question in exercise 5.2 also. X minus 1 over x is equal to 1. Now we need to approach that square plus 1 over x square value. We need that also. So applying square on x squaring on both sides. After squaring on both sides, we need to open the square of this. This is a minus b whole square time. So open this formula, that is a square plus b square minus 2a and b into say x and 1 over x. That is equal to y square. Why we are opening this square? Because we need this value x square plus 1 over x square value also. So this x can cancel to this x. And you are left with only minus 2 here. So this minus 2 will be positive there on the right hand side. So x square plus 1 over x square is equal to y square plus 2. Now we have two values that was our requirement. First is x minus 1 over x, that is equal to y, that we have already let. And second is x square plus 1 over x square, its value is y square plus 2. Now replace all the values in equation number 1. So put all the values in equation number 1. First is x square plus 1 over x square. That's why I was applying the bracket here. Instead of writing x square plus 1 over x square, you need to write its value, that is y square plus 2. So I am writing y square plus 2. Instead of x square plus 1 over x square, I have written y square plus 2. After that, what is there? Plus 2. Again plus 2. Remember that this plus 2 is separate and this plus 2 is separate from here. After that, minus 4 and minus 4 multiplication with x minus 1 over x. So what is the value of x minus 1 over x? That is y. So you can see that this is y square plus 2, that is 4, and then minus 4. Now make the square of it. This is a complete question. Make a square of it, just like in the previous method. You need two perfect squares. That is, first is y square, just like this is a square. After that, plus b square, mean to say 2 square, and then minus, this is a square, this is b square, minus 4y. You need to write it in the form of minus 2a and b. The value of a is y, the value of b is beneath this square, that is 2. So this is 2 to the 4. This is of the type a square plus b square minus 2ab. You can write it as y minus 2 whole square, or you can say that a minus b whole square. So y minus 2 whole square. So you need to make the square root of it. Apply square root, just like in previous question. Y minus 2 whole square. After applying square root on it, you can see that this square can cancel to the square root and you are left with y minus 2. Is this our answer? This is not our answer, because in the start of question we have not found the y variable. We started with variable x, but when we found the square root of it, we are left with value with variable y. So this is not the answer. The answer is you need to put the value of y. What is the actual value of y? That is x minus 1 over x, and that's it. Now you need to put that value of y, that is x minus 1 over x, and then this minus 1. This is perfect answer. This was part number 6, and in the next lecture we will discuss about part number 7 and the square root by division method, how to find the square root by division method. For today, this is enough. Now, if you have any question regarding today's lecture or previous lectures, you can ask it now, and thank you.